Hi, my name is Stephen Proud. I'm a electrical designer of 25 plus years of experience. The purpose of this video is to provide you a clearer understanding and to possibly accelerate your job that you're working on. Enjoy.
Okay, today we're going to be talking about a CMMO-ST controller. This particular model is a DIOP, which is a I/O controlled drive, and we're going to be using a EPCO 16100. 100 is a stroke, 16 is the bore size, and we're going to be using this particular device in binary profile. There's two different distinct modes, and before we can do anything, we need to make sure that we're completed with our wiring. So this document here is available on the website of festo.com under downloads and support. The first thing you have to establish is the wiring for the STO connector. That is the safe torque off. Okay. The other two cables here, the encoder and the motor, these are pre-manufactured cables. They should just plug in. You may have to terminate the actual wires at each connector, but the wiring here is shown as color coding goes, as well as in the manuals. Step 2 here is on the other side of the controller. We've got a power connector, and that is to provide logic for the controller and load for the motors. And the X1 connector over here is where all of our I/O for control of the axis is considered. I'm going to close this document now. I don't need this anymore. The next document is again on the website of Festo. A little bit different representation, but again the same 2, 3, 4 connectors. You've got the STO and you've got your encoder and motor. A couple pinouts for color coding. The STO, all this is a way to bring 2 channels of safety into the circuit of the controller. Here is a sample right here of an e-stop. You're switching 24 volts into here, and these have to be held high or turned on or have 24 volts applied in order for the power stage or the intermediate circuit to be able to be turned on via the enable signals. The opposite side again is discussed. We've got the I/O control connector, the X1 connector, and we've got our power connector, which is again our logic and load. And then we've got our Ethernet connection, which comes DHCP enabled. If you have multiple controllers, then make sure that you commission one at a time and turn off the DHCP server so that it can be on your network without communication issues and conflicts. You can only have one DHCP server on a network. The last document is my own document. We have in binary mode, we've got mode 0 and 1 for various reasons, and the I/O is shown here along with the color coding from a standard Festo cable, and that's our wiring. So as a minimum, you need to have the STO circuit activated, turned on in order for any control to be activated in normal methods. Okay, again, we're talking about the CMMO-ST with the EPCO. For the sake of argument here, I'm going to show you how to create a new project real quick with the FCT Configuration Tool from Festo. Simply create a new project. Click OK. Select the controller. This is important here. If you're trying to do an upload and you don't know what version you have, you might have to go to older versions. You have to create a shell first before you can upload. But for today's purposes, we're going to click on the latest, which is the 130. The 140 is a beta, so don't think that you have something or don't have something I have. Give the access a name. Click OK. At this point, you create a new configuration. This help right here is very important for newbies. You can turn this on or off right here under Dynamic Help. I'm going to leave this off, create a new configuration, hit the next button because this is the default. Could have a MPN instead of a PMP. Festo motor with axis. EPCO, give it a size. Give it a stroke. Then you get the axis and it will create a shell. That being said, you're not done at this point because you still need to go through each page and set up various things. So I'm going to delete this project and close it and go back to my already existing project here. So at this point, I recommend everyone use the next and previous buttons over here. You're at your start page, hit the next button. Again, I am discussing binary profile only in this particular guide here. I turn on a record sequence so that I can link records, which we'll discuss later, and then I have a couple comparators here that we may or may not use. It doesn't hurt to have them in the project. Hit the next button. Extremely important, all the gains are based on the load that you have. So 2.5, 5, whatever you have for a load at the end of the cylinder attached here, that's what the load is. So again, if you change this, hit the next button, this right here, read it. It says, the load's been changed. You want to reset all and recalculate the closed loop settings, which are the gains. Closed loop settings are right here, but we'll come to that after. So over here, this is something that you typically don't edit. You could edit it if you really want to, but we're not going to. This right here is something that's of importance. The quick stop is a standard deceleration rate for faults, e-stops. Well, depends on what kind of e-stop is, but typically you want to set this up for your application. The limitations up here are just limitations that the project will consider later as defaults. Homing switch type, again, we could have a limit switch. We're not using it in my case, so I'll be using block homing. Right here, block. So I could either say home to whatever position we're at, or home to block. We have to home because it has an incremental encoder. Cycle the power, you lose the signal. An incremental encoder is just a 5-volt TTL signal, so it's offset with a phase so that it knows direction and what the pulses are. So you need to home this axis every time you start up. The parameters down here are not really relevant. Hit the next button. Next, the software limits. In this particular application, we've got a 100 millimeter stroke. I'm just saying that when homing is finished, that right here, this axis 0 point. What this does is that when you home against the stop, it's going to move forward 3 millimeters because this is a positive number, and then it will define that position as 0. So when you get to the measurements, 100 millimeter stroke, we know that there's theoretically 3 millimeters behind that 0 reference, but I'm saying that the software limit is -1 and 99. But in theory, the axis might only be able to achieve like 97 because it's only a 100 millimeter stroke, and we've already used up 3, and you do the math. I'm sure you can figure it out. The next button, this is because this is only available after you've been online and saved the project. It saves this and stores this offline. These are standard settings. You don't need to change these at all. The gains, the gains should have been calculated automatically. If you don't feel that they're worthwhile enough, you can enable editing, modify these yourself. You could calculate them a little harder, and it'll modify these to suit. I'm going to keep where I had them. And then there's only 2 outputs that are physically able to be configured. You have a variety of things here. In my case, I don't need this for this time being. And then we have some default values. For this particular application, it's important. I've opened the windows up to the stroke of the axis as far as following error goes, because I'm going to be doing some position moves and possibly encountering opposing friction that may stop things, and the axis will not be traveling at its proper destination in time, and then you would get nuisance following error. So I've opened these up for this case. These are some default jog modes. This just means that when you press the jog input, it's going to go with the crawl, wait 2 seconds, and then go to a different ramp speed. If you don't like that, you can change this to the same 5 or whatever you want to do here. Then we have our record table. The record table is where you set up records to do a variety of things. In this case, we're going to, as I said earlier, we're going to extend the axis out. We're going to limit the amount of force, and when we reach our target, then we will return home. So in this case, I am using these moves right here to do the job. Okay, I've changed projects here just to get to the right record table here. I didn't have the right record table. So if we go back to our dynamic help, you'll see that when you're in here, these moves here tell you what they are. If you open up and double click on the record itself, you get a full overview of what each record is. When you click in the fields on the right hand side, it will provide information regarding the moves. And as I explained earlier, what I anticipate or what I want my application to do is I want to extend to 90 millimeters, and we are going to modify the velocity for each move. You'll see here that the velocity is the only variance here. I'm going to provide a force of 20%, which is based on current. My following error is 100, so that it does not follow, it doesn't provide an error. And when the motion complete is active, meaning it's finished, its move, then we're going to execute record number 2. And that's how each one of these moves are set up. Different speeds, so on and so forth. So, digital I/O. Now we want to go online. First thing you do is do a scan to establish the physical connection to your controller. Hit OK, hit OK, and now we're able to go online. In my case, I've already downloaded, so it's synchronized, but you may have to do a download. When you're finished doing a download, you do a store. Store. Yes. And now we see what signals we have. So you have diagnostics here. I'm going to delete all the diagnostics. All right. Monitoring. Manual move. Okay, manual move. See how everything right now is grayed out? You're not able to do any moves right now. That's because the enable's not on. So to get the enable on, we need a couple of things. We need the safe torque off. See how the safe torque off is off right now? I've pulled the connector out just to simulate, but we need the safe torque off to be active. The next signal is the control enable here. Okay, without the control enable, when you're trying to run with your normal I/O and not in here in FCT, if you don't have the control enable on, you will not be able to get the power stage active. So the first thing we do in commissioning is we execute a home. So block negative, I'm going to hit home, axis moves to home, and right now it's physically retracted all the way. Now that we've homed the axis, we have the ability to jog it. You press and hold the button to go in one direction. Same thing. The one above here is a relative move, so if you put in a 10 millimeter move here, 20 millimeter velocity, and hit this one time, it should go to 26, and then back. It's back and forth. If you want to execute moves yourself over here, you just come into here, add the move, and run move, goes back and forth. It shows going back and forth. All right, so you've programmed some moves and you want to execute the moves themselves. The yellow will indicate that it's been homed and is able to be moved. You press this once and it does it. I'm going to move to this here so you can see the target and the actual here. So I'm on move number 3, target of 90. It's going to move target 90. It's going to move out to 90. And then when it's finished, it's going to move back to move number 2 to there. Okay. The next move is just a little quicker. The velocity's changed. All the moves are set up identical except for the velocity. And you simply select a move and do it. A little quicker. Okay. Now we're going to go to controlling this drive or controller via I/O. The first thing you have to do is you have to gain control sovereignty from this device. So you have to turn off the enable, off FCT. And for this sake, right now we're going to go to here. Right now it's not ready or enabled. The control enable, the input right here, is being turned on externally. That right there is the DIN 10. This purple wire here, DIN 10 on the X1 connector. So that's what's turning off and on right now. And the ready digital output 10 is coming back to you on the pin 21 here. So the way that any record takes place is via the record bits here. So these record 1, these are binary select bits, okay? So you've got 1, 2, 3, 4, 5 record select bits, which are these ones over here in the green, and they will select binary from 0 to 31 decimal. The inputs, what this binary select does is it moves your pointer to whichever record you want to execute. So if we want to execute record number 6, we need to turn on record, this bit here, and this one right here. So this one and no, that one there. So 2 and 4 is 6. So now we've physically, even though it doesn't show it, now we're pointing at record 6. And the next bit that we need to turn on is the start. So where's the start bit? Start set execution. So DIN 6, which is the green or pin 6. As soon as I hit the start button, it will execute the move. Okay, it executed the move in the background here. I'm going to do the same thing. I'm just going to execute it again so you can see this physically happening. So record 6 is a move to 90. I'm going to hit the start signal again. It moved and then it came back out. Now I'm going to inhibit the axis a little bit by applying a force against the stroke. So I'm physically holding it right now. There's no errors. And I'll let it go a little further, and then I'm going to let it go. It's going to continue and then go all the way back to the starting position or record number 2. And Each time you want to do another move, you simply change the record. So if I turn on the first bit, now we're set up to program to move number 2, which is just a little faster here. And then I'm going to start over here, hit the start bit. And the start bit is a handshake. Okay, so when I turn the start record execution on, the set point acknowledge should come on, and I'll do that just by holding the axis. So I'm holding the start. The set point acknowledge goes off. Now I'll turn off the start. Now it changes transitions again. We're still on the move. Now I'll let it continue. So we're executing move number 7 right now, and then it goes back. When it's finished, the motion complete comes on. Only when the sequence of records is finished do you get the motion complete. So that's what you use to determine and get the full handshake. And that's about it for in here. Okay, the last document I want to show you here is, again, my document. I've got a couple documents here. This one right here. Okay, so this is just some sequence timing for record set control, which is what we're using, the binary control. And it shows you that we're in binary control. Talks about the digital I/O. Switch on power sequence. So this shows you here that your X3 connector, the STO1 and 2, need to be turned on. At this point, DIN 7, the halt bit, will be required. And maybe I didn't show that in the last video. This pause right here is called halt. It's always on. If I try to execute a command, right now I'm executing a command, and then I drop that, the axis stops. Okay, so if you want to continue, you turn this back on, and it will continue where it left off. But basically, this pause bit right here, which is in fact the pause halt right here, DIN 7, pin 7, DIN 7, pause halt. That's required to be high or on at all times for any moves. And getting back to this, the digital output 3 comes on, controller enable, DIN 10 is turned on. At this point, the ready should come back to us. The set point acknowledge is always high. The alarm, if you're using it, and motion complete will both be high. And now we're ready for FCT commissioning. So these are the signals that are required up to the point where you need to turn on and execute in FCT, which is why I wrote this down here. When we're executing records, as I detailed earlier, see how much I can zoom in here. The green is where we left off on the previous page here. The record select 125, that is these record selects right here. You basically select a record select. The DIN 6, which is the start, is then turned on. The set point acknowledge is inverse to that, so it will go off, and then when you get the acknowledge in the PLC or your third-party device, then you will turn off the start set, and the handshake will, of course, follow that. The motion complete will go off when the move is started, and when the move is finished, then it will go high. In our case, in this particular routine, because we're doing sequenced record sets, meaning we're we have a condition here where when we're finished this particular move, when the motion complete becomes active, it does not turn on physically at this point, this bit right here. It'll execute move number 2, and when move 2 is finished, which is the end of the sequence, then the motion complete will come on. If we in fact had multiple, let's say we had 5 sequence records, the motion complete would not come on until all 5 sequences were finished. And when the move's finished, motion complete comes on, the on move goes off, and that's it. Project done. Thanks, have a nice day. Hope this helps.